We're going to begin. All right, so I'm reading the question now. All right, everybody found the question? Question 2, just kind of about 4 pages, and you'll see the question. So it says here, so we're first looking at simulation, right, which is the compulsory question. Right? In reading about the swine flu vaccines, it is widely circulated that there are many bizarre side effects that are appearing. 1/3 of British nurses are rejecting the vaccines, along with over 4,000 physicians in the USA. A 14-year-old Virginia boy was hospitalized for 5 days after coming down with one bizarre syndrome, hours after receiving a H1N1 swine flu vaccination. Julian Beer is one of the leading causes of non-trauma induced paralysis in the world. He suffered an almost immediate reaction to the swine flu vaccine. Suppose the distribution to the left shows the number of persons per 1,000. So per 1,000 is underlined in the question and highlighted. Who get the bizarre side effects? BSc. Assume that each person who gets the BSc imposes a cost of $500,000 on the country, and each person found with a swine flu imposes a cost of $5,000. Since the effects are no more severe than the common flu, there is a cost of $500 to vaccine each person. The distribution to the right shows the actual percent that would have the swine flu among those vaccinated. A person can get the bizarre side effects whether or not they have the swine flu. Right? So, just looking at the question paper, this was the first distribution to the left on our table. Right? The table on the left here is the distribution to the left, and the other one right here is the distribution to the right. Right? The percentage of persons that is actually protected after vaccination is also a random variable with the distribution below. We assume it is based on the whole batch. Each person protected realizes a benefit of $15,000 for the country. There is a remainder that is not affected in any way. So they now give us a distribution for percentage protected underneath. After that, we have the health ministry plans to vaccine 1,000 students at 10 selected schools, 1,000 each. So from each school, we have 10 schools. From each school, they're going to vaccine 1,000 students each. That means in total it will be what? 10,000 from all 10 schools. Then after that, they now give us the random numbers to use in our simulation. You must identify every heading discussed. They must be shown separately. And then the question now says required, construct the appropriate random number mapping for the random variables for 6 marks. All right? So, for us to get 6 marks, if you notice, for the random numbers, they gave us 3 of them for the random numbers. They gave us, for BSc, 1 to 10, swine flu, 1 to 10, and percent protected, also for 1 to 10. So, this is the random number now for this question. So, I have right here, right? So, I have BSc. They gave us 2, 3, 4, 5, 6. Right? Then, right here, they gave us the probability. moment. All right. Then to construct the random mapping for this BSC, we're going to have to add 2 more columns. All right. So we have our FX column, which is the cumulative, and we also have our random number range, or just mapping for short. All right. So look at what I'm doing now. I want to construct the mapping for BSC. All right. For the FX column right here, for the FX column, it's just the cumulative of this column. We're just adding the probability down. So right here, this will be 0.08. This plus this will give us this right here. So this is 0.27. This plus this, 0.53. This plus this, 0.84. And this plus this, 1. Alright? Then for the mapping now, for the random number range, right? This is what you have to do. Right? You can either start off with 2 decimal places, right? Like this, or you can use 3 decimal places like that. But whichever one you use, you have to be consistent throughout. So you can't start off with 2 decimal places and then switch to 3 decimal places. That would be incorrect. Right? So, look at what I'm doing right here now. I'm going to start with 2 decimal places, like this, 0.00, and then I go close to this column at all times, close to this value, and I reduce it by 1. So this now is, my range now will be 0.07. I go close to 0.08. I reduce it by 1. Then the next range will be 0.08. So I start from right here, and then again I go close to this, 0.26. I reduce it by 1. So I'm maintaining my range. Right? If you look at this, for persons who don't know, this is 0.07. I reduced it by 1. So this would have been 0.08. Like that for this. And likewise, for this one, I reduced it by 1, 0.26, which is here, and 0.01, the same figure that I reduced it by. So this gives me 0.27 right here. So at each time, I go close to these values right here. Is that clear? So I have to maintain my range at all times. So the next one now will be 0. What? What will be the next one? 0.27, and I go close to 0.52. So everybody understand what we're doing now? All right, so this now is 0.53 to 0.83 and 0.84 to 0.99. Okay? And then we're going to have to do it for the other 2 tables that they gave us. Alright? So we also have to do it for swine flu. So let me have the one for swine flu right here. So we have swine flu. Alright, they gave us 4% on the question paper, 6%, 8%, 10%, and then 12%. And then the probabilities that they gave us was our probability 0.20, 0.25, 0.25, and 0.15. Then to do the mapping, I put the FX column, and I also have my random number. Random number range. Alright, I have my random number range, or just mapping for short. Alright. So right here, we're doing the similar structure. We have cumulative. Remember, the FX column is the cumulative, the CDF of our probabilities. So we're just adding them down. So this is 0.15, 0.35, 0.60, 0.85, and 1. Over here, our random number range, 0.00 to 0.14, 0.15 to 0.34, 0.35 to 0.59, 0.60 to 0.84, 0.85 to 0.99. That's for the swine flu. And then for the percent, let me put it right here. All right, for the percent. So for the percent protected, they also gave us 9%. They gave us the values in percentage. All right. 12%, 15%, 20%. Then we have probability. (0.18), 0.24, 0.32, 0.26. Then for our mapping, we have our FX column as well as our mapping or random number range. Right? So right here, check for me. We have 0.18, 0.42, 0.74, and then 1. Then for our mapping, we have 0.00 to 0.17, 0.18 to 0.41, 0.42 to 0.73, and then 0.74, and this goes up to 0.99. So that's in terms of our mapping. And doing all of these three will have given us 6 marks for this question. All right, so we now move on to B part. After going through the mapping part for 6 marks, we now move on to B part of the question. Question B says, simulate 10 batches by using the random numbers given. All right, we're supposed to simulate 10 batches by using the random numbers given. All right. All right, for this question, for this part, all right, you're going to need 16 columns for this question. All right. How will you know? I'm just letting you know at least in advance so that you know how to put it in your book. But I'm going to go through each column and you're going to see how you arrive at the columns. All right? It's actually 16 columns, but you can actually reduce it to 15 because we don't really need the last column. All right? So it either means that you're going to have to turn your book like this and do it across. But in my own case, I did 10 up here and then 5 underneath on the same page. So what I have down here is like a continuation, right? So we're going to have You're going to make the last 5 columns a little bit wider than the first. So the first column pali might just be like this, very small, but the last 5, make them a little bit wider because the numbers are a little bigger. All right.